Hello and welcome to another one of these ADD videos. Today we're going to be looking at the concept of first order differential equations, specifically how to solve them using the substitution methods. When we're dealing with these first order differential equations, there are the exact equations, separable, non-separable, but try to keep an eye out for specific patterns. One being the homogeneous pattern, z equals y over x. If you can get your differential equation variables to be in the form of y over x ratio, then you can do some work and make your problem a lot easier by doing this substitution. Or if you can also recognize a pattern in which you have an ax plus by form, alright? Sometimes you can also have plus a number here and then make it into this form. We'll talk about that later. Or finally, the Bernoulli. I will do Bernoulli its own video. It's a little bit more complex than the other two. Alright? So, the basic format for these is pretty much the same. What you're going to need to do is you're going to need to first make the substitution and then find out what dy dx is. Alright? So try to get in the problem in the proper format. So try to make it into the y over x form or the ax plus by form. And then we have to find dy dx. So if we are doing the first substitution, first multiply the x over to this side, and then we're going to take the derivative of all this with respect to x. Keep in mind both of these are variables, so we have to use a product rule. Or we will do this substitution where we have the derivative of this expression. No product rule needed, a and b are constants. So when you do that and take the derivative, you end up with this here. Product rule says derive z first times x with no change plus the derivative of x is 1. You don't need the dx, they cancel out. And then times the z with no change equals 1 times the derivative of y with respect to x. Here, this is just straight derivatives. You don't need the dx. Here, you do need the dy dx. Alright? So once you get that, you would plug into whatever your differential equation is. Everywhere you see y over x, a z. And then plug in your dy dx in terms of z's and x's at this point. So then it'll all be in terms of z's and x's, whichever substitution you did. And at that point, hopefully your problem has become easier and it will turn into a separable or non-separable first order differential equation. So if you don't know how to do those, first thing you should do is go back and review those two techniques. Separable, you just get the x's on one side, y's on the other side, and integrate. This one, you have to find the integrating factor, a few more steps to it that you might have to review. Alright? So this is just an introduction to the concept, get the ball rolling. Check out the example videos for a little more clarification. I hope I've eliminated enough doubts for you to get started on these substitution problems. Make sure you check out the Bernoulli equation concept video, which will be separate. Practice, practice, practice is the key. Thank you for watching. Have a nice day.